Thank you very much for the introduction. Yeah, normally I don't get as much time, so I might be when I speak very fast, so I'll try to be a bit slower. The agenda for today is I will describe more things about me and maybe make you listen better or worse, I don't know. We're going to talk about like what is data versioning and what it's good for and what the hell is it and why do we need it. And if we get to that part, then we're going to go like, okay, but how? And at that point, we're going to look into a project as a demo. I hope that many of you did the setup, so we can skip that as fast as we can. But if not, we're still going to give it some time. And at the end, we're just going to go over all of this stuff. In between, I will try to put as many kind of best practices and tips and tricks and all kind of things that relate to machine learning, especially in relation of technical and deployment elements. Yeah. So can I ask? I don't know if you can do it on Zoom. Can we ask how many people here have done the setup, or can I have experience with data versioning? Well, it's look like the chat is empty, so I assume people are still waking up in some places in the world. Okay, so let's start with me. I'm currently the head of AI in Lasso Security, which is a company who does cybersecurity for large language models. Um, I've been in startups in different types of positions relating to machine learning for the last 10 or so years. I am not a founder, but a founder's engineer, which is a guy who put all the efforts in just like the founders, but take none of the risk and also doesn't get as much of the of the winnings when you get to that point. So founder's engineer is still very nice, but I won't get millionaire anytime soon. And as I said before, I have all kind of hobbies. I'm 37. I live in the Netherlands. I have a daughter, and she's still cute. So far, so good. Um, in this point, I would love to know who here has some experience with Git. And again, I'm looking for the chat to kind of see any reactions. Oh, we have Bertil, Mr. Hat. It's nice. So I guess everyone, this is great statistics. Everyone who answered has experience with Git. But just for the sake of completeness, let's understand the shortest, most clean explanations ever done on Git, I hope. So when you code, when you work, you have your file system, just the things you do. Then you can upload it to kind of a staging area by adding it. And then when you're happy with it, you commit it, and now it's a part of your project. And you can revert it with restore commands. And if you want to, you can go and take the original code or anything you have that was sitting in your repository by checking it out. And you can push and pull from the cloud to kind of get to kind of sync with other people's work and put it on the cloud and so on. And Git does a lot of other things, but one of them is diff. You can look at what you did before and kind of compare to know what's going on and the differences, and it helps you to do all kind of magical stuff. Now, if you've never used Git or you're very new to programming, this is going to be a very difficult workshop, and that's fine. Like if this is not something you're very comfortable with, just add in, commit in, pull in, then this is not the workshop for you yet, and you're welcome to use the recording later on when it makes more sense. Now, there is an inherent problem within Git, which is, let's say you are a developer and you're working on this file. Let's say it's a movie. And every time you edit it and you cut a bit and you add a bit, you make small changes to it. In the background, Git saves the history of what your file was before. As a result, for every change, you have a full copy of your file as is. With text file, it's not really an issue, but when you talk about images and movies and so on, you can get to a point that with the many changes to your files, your history is getting huge. and then your boss is cloning your project and his computer explodes. In reality, Git just doesn't let you do any of that. It just doesn't let you add and commit and push big files. It just blocks it because it doesn't want your boss to fire you for making his computer explode. So what do? We use blob stores. You just have a bunch of, in this case, this is an S3 with not fake names. And you just have a lot of locations that are very resilient and you can easily upload and download, and it's safe and it's very cheap to keep the data there. Whatever you need is very easy to upload and download in big scales and volumes and so on. And in our context, when we talk about machine learning, then you can think about it that you might have a few projects that you're doing within your company. And then for each project, you might have a few different environments, and each environment might also have like different stages of the data, so phases of it. And then for each one of them, you might do different models as you develop. And for each model, you actually might do a few experiments that might be related to that model and that data for that project, which you also want to monitor when that specific model is running in production or running in an experiment. You want to know what is the prediction that it does, and you want to relate to it. And also you have the other logs that the app has that sometimes is relevant to how your server is working, because the predictions is part of the server sometimes fall on the MLOps or the machine engineers, because he knows what's the inputs and the outputs. And there might be other assets like images or like vector index or other files that you also want to make sure that are up to date with the model that you are currently using, and it can get out of hand. Now, that's not even the only part of it. This is just having it in a place where you can store it. You still want to be able to know which model is in production, what code and what parameters that model is using. What was the one that we were using last week? If I want to train the model again, because the EU decided we cannot no longer use data that comes from Russia. So from now on, you need to adjust your models. So how do you take that model and remove that specific data? Or even answer, does the data use Russian input? Yeah. So on top of it, when you have the monitorings, there is a lot of time disconnect, or you just pay for another platform to do it for you to monitor over there. But then you need to manage like your relationship with that platform, and obviously the costs and the learning curves and so on. And if you have multiple models, you want to track what was the parameters. Maybe it's because you got more data. Was it the algorithm? Is it the feature engineers? There is a lot of things to consider that you want to be on top of, and they're sitting on different places in your bucket. And even when you want to revert, you want to know where the model is that you want to revert and why and so on. So often enough, data scientists are sad, and this is overly well, it's actually not overly complicated. This is a standard solution. Nothing here is special. You build your code and you save it on Git, and then you do some pre-processing and you clean the data, and you sometimes keep it in another place as an intermediary result. And then you do training, and some of the data goes and you run a bunch of experiments, and all the experiments you save the models at some place, and the best model maybe go to production, and the other ones are saved as backups in case you need to revert, because stuff can happen. And your server is sending the monitoring data to a different place where your data scientist, not your machine learning engineer or your machine learning guy who solved that problem, he goes to that place and he brings the data and he writes his own kind of code, and it might be completely unrelated, although it goes about the same models and about the same data and problems. So there is a lot of common knowledge that is lost or turns into friction between teams. And then when it's the monitoring data there, you have offline and online experiments. You need to write this code, so that also goes into GitHub. And maybe you want to do some alerts if the predictions all of a sudden are all zeros or make no sense, or the data drifting, and you get that whatever distribution you had on the model originally is not what you're seeing now in production. You want to have an alert so you can react, so maybe you can retrain and so on. And this is just normal. This is just what you do. You just figure all of this out and you write all this code and you use some platforms for some stuff and you figure it out, which is difficult. So what is data versioning? You just check out a version of a model, a tag, a branch, and the data is there, your monitoring is there, the experiment tracking, the code for the inference, the code for the training. Everything you need is now at your hands, available for you to work. That's it. You don't need to keep track. The files that are here are the files that you train for the model. And if you want to train a different model, then you get the right files, but then you just commit them like any other file. The data versioning, and in our case, we use it for a lot of different things besides data, is just about having everything just handled by Git in the same way. You can version it, you can much easier break your data, delete a file, restore it, get it back, download it. You can feel way more comfortable. I know of so many people who just take their data and they want to do some changes, so they copy it to their desktop and then they do the changes they want. And then if something is wrong or whatever, they need to bring it back, or they need to just, they find a place on S3 or the whatever blob store they are sitting on, and they're putting it there, and then they're coming back. So you have to kind of take all of those things into consideration. And why? Just do the change and commit it or restore it like any other thing. Be great. Same with logs, same with tracking of machine learning, same for your model. You just broke the model because you did a test, you override it. Okay, it's fine. And it also includes for your inference server. Sometimes that's not done by the same machine learning engineer who built the model or designed the model, but often enough it is, because there are so many similarities in the knowledge necessary, because the guy who worked with the model can tell what is the raw data, how it looks like. It can tell what the server need to do on the way and build nice pipelines and so on. That's what data versioning is. And it's nice. So, okay, we got to this point where if you have any comments, I can see them here. So write them down so I can react to them. I would like it to be as interactive as possible. This part is a bit, obviously I'm talking a lot because it's my workshop, but I would like you to have questions. And if you have anything you want to share, just put it on and I will say it as well. So it will be recorded in the internet forever. So I was working for ZTAB, for a data versioning company, before I became the head of AI in Lasso. And I was working on this framework that kind of figure a lot of the things out and help you kind of manage all the new possibilities. Data versioning was there for a long time, but it is a pretty niche tool that most people do not use. So I wrote this article, and you can see here that I edited it to look like I got 2.4 million claps. And we're going to also look into a demo project where everything is implemented, and we're going to go and have a look how it looks like and what it means in actual project. And at the end, we're going to have, everyone here is going to have just a bunch of commands where we can kind of play with all the automations and the things we need to make it work. For tracking, we're going to use MLflow. Now, if you have never used MLflow, it's one of the more popular tools for machine learning experiment tracking, and it has also all kind of versioning of models as well. I don't know if it's my favorite, but it's very popular, and it works very well with all data versioning tools because it makes a lot of files. So the concept that is the biggest part that we're going to deal with is about how to actually use branches and tags accordingly to kind of be on top of everything. That's the main point of this workshop. And if you take only one thing, that can be a thing. We're going to work in a common workflow where you try to always merge kind of to dev and only from dev to prod, which is pretty standard. And we want to use many of the Git standard tooling and standard workflows. But in general, it's just about how we manage it. There isn't a lot of proprietary tooling and crazy ideas. Some of it is a bit creative, but most of it is very standard. It's just me trying to develop a bunch of different projects and deploy them and see what works and what's not. So at this point, we're gonna, for data version, we're gonna start getting the project up. So we're gonna use ZAB, but everything that I'm doing here, you could also use DVC, which is a very popular data versioning tool. And I don't think everything can be done with LFS, which is the second most popular tool, or other um, data lakes who have data lakes that also have Git capabilities, but you can definitely integrate those ideas to all of those. Specifically here, I'm still an advocate at Spirit at ZDApp, and I think it's a great example of how to do it better, in a sense that everything is just being done behind the scene and you don't do too much. You don't have to manage files directly and do a lot of work. You just work with Git normally. So at this point, we're going to go into a setup, and this is the ugliest slide in the whole deck. And that's the fault of the people who didn't do it yet. So I'm going to give a few minutes for people who haven't been set up before. What we want to do is we want to sign in, which is you can just use your GitHub account or just any other sign up that they have there, and then install the CLI. There is the instructions. It's, yeah, you just get, you have three options and you choose them and you press and you double tap on it and install. Then we're going to create a token and kind of authenticate, and that will take care of all the permissions. You can go on the website following those instructions, but you can also just take this shortcut because it actually works for every user. Then you're gonna, when you create a new token, you're gonna get this line. It will have the actual values, and you just run it on the terminal where you're gonna work. Following that, you can duplicate and clone. So duplicate is just a version. You can go to this project, to this demo project, and duplicate is sort of like fork and change ownership. So it's the origin is yourself. You don't go back to my project. So you can do all the changes, and it just becomes your project forever. And then you can clone it. Your username is going to be here. And when it's cloned, you can cd in and set up your virtual environment, install the requirements. And this alias just make all the CLI things look a bit better. And at the end, if you run demo, and this is two dashes, --help, and you see the help, then you know everything is okay. Now, in this point, I'm going to give you a few minutes to do it. And for the people who already did it, I'm going to give you this. Okay, I don't see a lot of reactions, so I assume everything went well and everyone is already on board. And if you're not, then you can still do it later. It's fine. Okay, so we saw a lot of funny babies, critical for any good presentation. So we go back. We want to see branches and tags. And here we're going to go straight into the code and the examples, and we're going to go from one to the other to kind of understand what we want to do. So let's start with the main branch. Often enough, we use the main branch just for, we use it for the latest version of all of our code and the accumulation of everything we did so far. But this is not what we want to do in our data science machine learning project. We're actually going to use it for docs, for a place to kind of have discussions and understanding the business problems, the data we get, how we collected it, kind of the requirements we have. This is the place for collaboration. This is the place for documentations, for you can also use this place for tracking of experiments. So you can go there and kind of see all the experiments. We're going to go and talk about it a bit later, but you don't have to. And it's a very kind of empty, basic place that anyone can just download and kind of figure out what the project is about. And the discussions are held there. So I'm going to move into my code. And let's see that this is working. So let me see. Can you see my my code? So this is a pretty nice example. This is mostly a README. All the other folders you see on the side are there just because I wanted the help to just work. So ST is just a shortcut for Git status. So you can look here at all the files, and the main thing is this thing doesn't this thing doesn't need to work in theory in the main branch. So, but what you would like to have, so this is an overview of all the branches we're going to have and all the branches we're going to discuss. We are now just in the main branch, and there is nothing that you need to do here. I left here the instructions for the installation and the setup just in case. But which you might also want for your project, how to install, how to get all the packages, which technologies you use, and so on. And you want to put information about your data and the problem you have. So in this case, I took standard diabetes datasets that you can get from scikit-learn. This talk is not going to be, it's not going to be very focused on the actual machine learning aspect, but on the solution architecture of the code, of the solution architecture of everything around it, and how you would put everything together. You can build better models probably with another 10 minutes of concentrating on that exact thing. So here I describe the size of the data, which might be able to change, but how you collect it, what it means, the features, what they mean, and so on, and which evaluation you want. So here I decided of a root mean square error because it's a regression problem, or this are we going to address it as a regression problem? And we can have a discussion here of what we need and why is this one better or another metric can be better. And there is a small distribution here you can find about how your data distribute. Doesn't need to have too much, but it's just a place to kind of bring everyone on board. Any questions about the main branch? Should probably look. No. Perfect. So I'm going to change back into the slides to consider our next one, which is, yeah, what I just said. We're going to have the data set and the examples. I wonder why there was such a big blank in the middle of the slide. That doesn't look like me. I know how to use all the space in the slides. Have a small place for my head at the bottom. So let's talk about data branches. Now, those are very interesting for what we want because it's one of the examples of how we diverge from just any other project. So normally you have your data probably in a specific, the data in a specific bucket, that is the data bucket for your company, or the data or the specific project data bucket that you have, and you might have different kind of phases for it. This is the same, but what we're going to do, we're just going to have it as branches. So you just set it up to have a branch instead of just having, and that's kind of managing both the upload and download and all these aspects of the data, but also the relationship between them. So all the data comes in and it goes into raw. And if you can take one tip that is related to this kind of view of your data, always upload to raw. And from raw, do all the transformation changes to other places. So if you start changing raw, you kind of lose, you lose the linearity, and you also commit yourself to kind of working from a specific phase of raw. It's much nicer to, raw is just where you upload everything. And then if you do a change or you split or you do any kind of processing, you put it on a different branch at the end. And we're going to look on how you move things around. It depends on the technology, but in general, it's just like copy files. And so you can obviously do it with any kind of integration, like with Spark or any kind of batch jobs and so on. It's not uniquely special. You just apply it and you just commit it to a branch and not just uploading to a certain location. Now, what it gives you, one of the best benefits, is that it takes those very unclear, very complicated, long kind of addresses, which is the way we manage the actual data. This data belongs to this environment, on this project, on this version, on this date, on this aspect, on this algorithm, on this date. This is where the model is. It just turns it into the only model you have locally and the only model you have for that use case. So all the addresses becomes very easy also on your server side when you want to load things or when you want to manage them. And hopefully we're going to have some time to look at data analysis where we just take a model from any branch and just use it to do an analysis without getting too complicated about it. Now, I like this idea of putting like data that you see as you upload it to raw and you see it's broken, you can just get it to corrupted and you can make those automations later on. It's the same ETL operations you would have done anyway, but now it just sits in a place that you can always address it. And if you want to change your workflow, you did one type of split and now you want to have a different split, or you want to first clean it and then split it. It's very easy to go to raw and just create a new branch from raw, do the changes you need on the new branch, and set the automation to go there in the new way. And the code that does the automation can sit on the new branch. The code that does the ETL is sitting on the data branch. So branches are also free. So you just make one for dev, one for everyone. You can run it, you can develop on it. It's really nice. And you don't need to feel shy about it. Now, there is an important aspect here, which is data copy. An inherent feature of all data versioning tools is the file deduplication. If you have the same file in different branches or different locations, it will not make a copy. It will only save a link to that place. And that is extremely important when you do a branch. You don't want to pay for copies for everything, which you often do in the original way. When you have this project and then it's another project to use similar data, you copy everything. Or if you don't copy, you have to manage the addresses of the old one. And then if you change that, then your new project is broken. So often enough, you copy and maybe you do processed, but not everything is processed, or you add some new features and so on. You get a lot of duplication of data, which you pay for. It's not the most expensive, but it can get out of hand pretty easily. Now, an extra feature is a file deduplication or chunk deduplication specifically, where if you have a file and you make it bigger and bigger and bigger, then in that case, only the added is changed, just like any other change. You only pay for the extras, and the chunks are managed as pointers. And that gives you a lot of benefits in use cases where you do train and test splits, for example. You don't pay for the train and test again as new data because it's the same chunks of the original data. So you can have your file and the train and the test and everything, but you actually pay for every chunk once. And it's great when you add extra features. Often enough, it's something you either do in a lazy evaluation manner, so you don't have to pay for it, but then you pay for it for in inference time, which again, it's something to consider when you work with big data, but otherwise it's just great that you add the new columns and you don't pay on having everything together. You don't have to make one file for this and one file for this and so on. So it can save you a lot of work. It also is very helpful as kind of a cheat. When I do a monitoring, I'm just I'm extending the file and I'm just uploading again, knowing that behind the scene, the chunking is just going to take care of everything. It's only going to upload the new chunks. So I don't actually need to go like, oh, the last row I uploaded was row 100. So now I want to upload from 100 forward. You know, it's taking care of you in an efficient way. It uploaded in a very efficient way and so on. So chunk deduplication is a great feature for machine learning. And we can rely on it whenever we have a lot of situations where it feels like you create copies, but you actually don't. Yeah, this is the main tip of the day. Always upload to raw. So how does it look like? You have your data branches, and when you check out the data folder, in this, I like to put the data in data because it's data, and so put data in your data, makes sense. And you can either check it out or just use a CLI. Now, and what happens is just you get the new files. So you can think about it that behind the scene, the server or wherever it is, it uploaded data, and now the data is committed to that branch. So the branch, which is kind of like the same place as your bucket, has more files. When you check out, you get the new files. And in many toolings, you also have like a CLI, like a copy or other tooling that you can do. In ZAP is set Z copy or like CP, kind of like normal copy. And that kind of makes sure that you can always get the latest version of the data very easily. And if there is other flows and other elements that are behind the scene, the data scientists get way less pain and doesn't need to concentrate about those aspects. You just, if something happened and someone figure it out, then whatever data you get, when you check out, you're going to have that new data. And it helps you again, it helps you to manage. You can also manage it with a database where you have a database and every time you kind of do it in chunks, because if you do it all at once, then your database is too busy working for your requests. Well, now it's very to create dumps and give you all the data and export. So often enough, you rather do it in chunks and in now and then you need to remember which one you were the last one you did, which you can also do in a database, or you can also check your files and figure out what was the latest and then make a query that adjusts those times to get it. So this is just simpler. You just check out, and if the guy just upload it to the branch, this is taken care of for you. Oh, it's one of the nice benefits. What? Let's go and look at data branches. So changing back into the coding slides. Oops. Oh no. Can you see me again? No, I think it disappeared. Let's hope everything is okay, or I'll have to go back into kind of, oh, no, it is okay. Oof. Nice. Oh. Setup here is challenging. So you can see now, you can see my code. So I will just check out the raw branch. So again, I have a shortcut because I do a lot of this kid stuff. So it's just check out into raw. And now there were updated in the raw that I didn't see. Wait. Think we are missing some of the images. So materialization is when you have a file and it's just the pointer. Before I did this thing, all the images were just pointers. It doesn't download them unnecessarily, only if you need them. So in this case, I materialize it so we can look at the README. So this is my raw branch. All the code I have here, the only relevant part, I can delete the other ones, but again, I don't want to ruin the CLI for this demo, but I just have like a data kind of object, and it's just a helper that manage a lot of those elements. So behind the scene, this is how I get the original data, and I can just do, and I implemented just doing like to add rows and to split, which will move it into the split. So we can have a look at how it looks like, but wait. So if we look at the data, I have data, and let's see how it looks like. In theory, here I only have like a single file. Do I have? So if you can see here, make sure you can see it. Yeah, there is only a single file, and you can, for the sake of this example, this is our source of origin. This is where the server is just uploading all the data here, and there is a single file, and that file it can get bigger and bigger. So I can go and do something like, this is how it looks like. I can do demo, data adds, and add a bunch of rows. And now what actually happened is I just sample a bunch of rows and appended them, again, for a toy example. So you can look at the add rows function. And this is how you do it with ZTab. It's implemented of FS Spec, which is kind of a tooling for working also with Google Cloud and S3 and Azure buckets and so on. And I just read straight from, again, my location at the raw branch, the data file. I just read it like it's any other place. And this is something that's very easy to manage. And these things are just set by kind of automatic. So here you can have this as a constant, but for the sake of it, it's just fine. So you just read it. I sample a few more rows, I add it, and I just write it back into the same file. So now the file is just 100 rows bigger. Now this thing actually wrote it into the cloud. So now I actually locally, because this can be run anywhere. This can run on a Lambda, this can run on a server. Anyone can add data to the server. I don't have it currently. So I need to do a git pull. Let's see if I need to do, and it looks at it and it's angry with me because it's a demo. But yeah, I just added a bunch of rows and deletions, and it's the same file at this moment. But the point of it, I just pulled it and I got the latest version. And maybe I'll get a better time if I'll just do it again now. This is the raw branch, and all the files should be uploaded here. It's another silly thing. I'm also looking to see that the change was the last one. This is for me for debugging. And now if I do git pull, I get the new data. Yeah. Yeah. So yeah, just got more data. This is a way to work with it. And again, if you want to do some analysis, you can just you just check out the raw branch, and now you have all the files and they sit there, and you can run some analysis if you want to just look at things or build some automations from the raw file to another one. So let's go into the split branch. Now, split branch is a pretty weird name for a branch, but I felt like for a demo sake, it works. And here, what we got is all of a sudden, we just have the files here. They just arrived. So again, I don't need to bring and download. I checked out the branch I wanted, and the data is just waiting for me split. Now, again, there is a small tip for machine learning engineers is that you might want to consider the benefit of having the split as part of your branch and not being like run as with a random seed, which is constant or that is decided on training time, is that if you're collaborating as a big team, you're all working on the same place. So you're all starting from the same split. You know that your models and the different training jobs you do, they're all working on the same ground. They're all evaluated based on the same data. So you're saving a lot of friction and problems you might have with that. So it's a benefit. The alternative is that you can also just run the split in on the fly at training time. And it might be, again, if you're using big data and you are smart about the way you do it lazily, which you can do, where you split it and then you just read lazily just the data you need, it can be more efficient, but then you are more susceptible for bugs and issues with collaboration and so on. Any questions? Very special. Thank you. Thank you, Mr. Hat. Have a nice day. Okay, and then this is the split branch. And again here, just if you want to have a look, I can do demo and data split. And now, because now we're talking this, I run it here, but again, I'm simulating a server running it as a ETL behind the scene. So behind the scene, when I do the split, what would actually happen? Oops. Boom, boom, boom. Is that I will look into the data, the latest version, right? Because this is the latest of the raw. And then I do a new split. And this is a very common, again, another tip for machine learning engineers. You want to have a train and then the test you split into validation and test. And you only use the test set once, and you can use the validation test for all kind of hyperparameter optimizations. But the moment you start using the test file again and again, you kind of cheat yourself because you get to a point where you start optimizing yourself to the test set. So you want to use train, validation, and test, and then I just save them straight into the cloud. So now again, the data is in the cloud. I don't have it locally. This is all running behind the scene, and I'm working, and I'm very happy. So I need to go back into my system and do git pull, and hopefully I will see the changes. Yep, I got the new rows for each of them. And there are some parameters here. So everything in this demo is using the Great Typer library. So you can do help on it and kind of see what are the different options, the test sites and the seed if you want to run an experiment with other elements of how it could in theory run, and also to debug yourself. So this is our data branches. And if there is no other questions, which I don't see, it's only my questions, then well, I have a lot of questions. So let's go back into our slides and consider the next part. So can you see my slides? I don't think so. Yes. So this is the developer branches. Those are the more interesting ones that we're using. All of your code is written here. And we have two types of those. You have active branches or active branch. This is a branch you never delete. You always keep it. And it's kind of like if you're a software engineer, you often do it. You have a dev environment where you put all your nonsense in, and then you have a staging and a prod. I skip the staging in this case. You can have it, but in general, you just everything is ending up at dev. You see that it works the way you want it, and then when you're happy with it, you send it to prod. And prod only gets from dev, and then it saves you a lot of issues with merging and some other elements. Now, you can also have feature branches. This is another standard of Git when I can develop a specific model. And I start in this example, we start with a baseline model, which is just getting the average and always predict the average. And there are a lot of benefits of doing it because you get a good baseline of your problem. You can evaluate it, all your other models next to it. It's much easier to develop. And it gives you the space to develop other things you would want early on, but don't prioritize often, which is model monitoring and model tracking and other elements. You do all of those and you just put a very, very simple baseline model. So, and those ones, you can delete them afterwards. No, you don't need to get married to any of those ones. They are not active branches, they are feature branches. Now, it's very important, in my opinion, to only code in dev. It's kind of like you don't want to code in prod in normal in standard software engineering. It's really nice that you have everything condensed in one place and you can always figure it out and you can play with it without breaking any other systems by accident. So just code in dev. Now, an extra layer of it is the use of tags. And this is something I'm a big fan of. Is let's maybe talk about kind of Git labels. So the head where you are now is a label of a specific commit. Branch name is a label that moves with you. Every time you commit, you get a new commit, and the label of that branch is moving with you. And a tag is a label that stays on that commit. So if you do any change and you commit, your tag is still showing you the latest version. So often what I like to do is when I'm done with the model and I feel like it's ready, it's working, all my tests are passing and everything, I'm very happy with it, then I tag it. And now, even if I delete the branch later, I can always go back to this place. So if I have some code I forgot, or I want to have a look at, or I have a bug and I want to see if I had it there, I can always go back to that place. And I like to kind of automate it. So we're going to use it in this case. I think today there are still not enough tooling for kind of Git data versioning stuff. DVC have a lot of CLI scripting that they're doing, but I think that we are still in the early stages where people are going to start using it and start kind of have a lot of those tooling to make those things simpler. But this is the commands that you can always use with Git to kind of tag things and remove tags and so on. And in our CLI, we also have kind of a shortcut for it. So yeah, what you can see in this case, another element that is very nice for this kind of development branches is that you can maintain intermediary results. So let's say I was developing a just a linear regression, and decided to also use PCA. PCA is not a very heavy computation to do, but assume it's something bigger. For example, embedding to a vector of images or text or so on. Then you want to do it once and kind of have it there with you. You don't want to read it again and again, redo that again and again and again. So it's really nice that you can develop in your script that you just, after you run this, you save it and you commit the data together as to replace the original data. You don't keep one data train plus vector. You just keep only the train and you just work with a single file that makes sense. And yeah, so let's have a look at how it looks in our project. Okay, you go back to code, yes. Okay, so in our case, Hopefully there's no issues. I'm going to go into dev. We can go into dev baseline. I don't think I deleted it. Yeah. So this is kind of our baseline model, and I need to refresh. So why aren't you doing that? Yeah. Is everything still working correctly? Yeah. So in this case, you know what? Okay. So this is our kind of dev baseline model, and this is a really good place to kind of have all the benefits of what we talked about earlier. And maybe it's a good time to kind of look at a general software, one nice framework or kind of a design pattern that I'm a fan of. So obviously, you can see that there is a lot more things here. I have the file, the original one, as we said, the train, test, and validations. And we use MLflow. We're going to talk about it later, which creates this MLrun folder for us, where all the experiments are running. The notebooks are relevant at this point. And models where we're going to save the single model we have. Now, sometimes you might use multiple models, for multi-staging models or other elements, or you have more things. So I like to put it inside a folder. And the prediction is every time I train a model and I evaluate it on a test set, I also save that test set as well. It goes with it and I track it. And later on, I can see if the model does something funny on the data. I can just check it out and see, oh, this is literally the data that it did, and this is the tag that it had, and this is the prediction that it gave me. So I can track back where it goes. So we're going to go into it when we're going to talk about stables, but here about stable branches. But here what we can already look in is to kind of like the way of looking at a very standard kind of way of deploying models. So in this case, I implemented a mean regressor, and I'm a big fan of using like the scikit-learn kind of wrapper around it to make sure that the fit and the predict and everything is implemented the way I would like it. And if I want to have optimizations, I can do it here. And the trainer, it depends again on the scale, but in this case, it's just the object that kind of manage all the training aspects. It knows all the parameters, it does the evaluation. I don't need all of this to do predictions in production, but I would like it to kind of manage everything around it. So the interesting part about it is something like our fit function, and this is where we look at the MLflow. And MLflow, I give it all the params that I think is relevant. And in the real production and setup, I will have a lot of things that I will care about here. And I take this data. Again, this is not very efficient this is not how I would do it if I had really big data, but I'm giving myself a bit of an easy out, and I create one version of with the splits where it just read them from local, because again, if I want to have them, I just pull and I have the most recent data, which hopefully we should be able to do. So sorry, git pull. Yeah, so it already has the latest version, and then I run one experiment, and then I retrain on the entire data set. Now, this is another great design pattern that a lot of people don't do, but sometimes you train and you do all kind of, you do a train test validation or kind of a different splits, and at the end you take the best model or one of the models and you use that one. But in actuality, you probably do want to use the one that goes into production, you want to have all the data trained on. So it has the most amount of information, and it can do the best, kind of get you the best results in production, where we're going to monitor on what it's doing. So even though I trained the model once here, and this experiment is actually not very sophisticated, is obviously pretty easy. I just go, I fit the estimator, which is exactly what you think it is. I just fit it with the data it ignores anyway. It just counts what is the average and just keep that value. And after I train it, I create a prediction. And the reason I added it, which is also why you'll get a bug if you do changes to this thing. And then afterwards, you're trying to create the old data thing, because you're going to have one more column on this one. But in this case, I can go I can evaluate it, and then I can log the results of the evaluation and also log all the predictions. And that is how later on, if I have issues, I can go back and see, wait, when I evaluated the model, why did I get, I did so well? And I can find out that maybe the data I use was very biased, or maybe my model got to look into, there was data leakage and the model got to look into data it shouldn't have because this test I was training here or something. Like it helps you to kind of always be on top of things, even when you go back into them, like kind of good documentation does. And we have this tag, which we're going to talk about in a second, which I always add as another element that kind of pin me to a certain point. Now, there isn't too much more. At the end, you can save the model, and I implemented that we save our predictor into a file. So you just make sure that there is a folder there and you save it. Another aspect of it is the predictor class. Now, this is a class I'm a big fan of, not specific the predictor, but the idea of having a wrapper that has your prediction model and also all your metadata. In production, I'm almost always don't do predict, but I do it transform. And the reason is that when I get a prediction, even if it's a single one, but again, if you want to scale it, you can send predictions as a list or as a JSON often of records or key with a value of arrays. And at the end, you can do predictions of a lot of them in parallel. But I would like, when I monitor, to be on top of all of these different elements. So I don't want just to know what data I had, which is my X, and what prediction I gave, but how long would it take me to give it? Maybe my model is too slow. What time it was. So of course, I would like that thing to be on top of it. And other elements that are relevant. Where can I find that model later? So we're going to go over the rest of them, how we use them later. But this idea of using transform, and then on the server side, the server, what it does, and this is a very classic fast API server. So this is a standard way to do it, where you have a models and you manage the life cycle of the model. Well, find it, the life cycle with this element. This is kind of more latest version of, well, I don't know when you're going to watch this talk, but currently it's pretty latest way to do it, spelling. And you want to make sure that you have a place to write the monitors, and then you load the model, which is just putting it inside this model tooling. Now in Fast API, it's very nice to have kind of base models or tools that it gives you automatic documentation. It does some validations for you. It throw the right errors for you. It's great. You really want it, and you make an example here. And when the loading the model is literally just loading it from wherever I saved it earlier, and then during prediction, I just go transform. The reason I have this predicting, we should be model transform actually. The reason I have it here separately from the actual server, which is this app predict, is that I would like to first, I get the predictions, I send a task to the background to log those, and it adds behind the scene, and any now and then it's going to upload that CSV behind the scene. And at the end, I just take the latest prediction and I just take that one. So I don't have to so I don't have to send back to whoever did the query all the information. I still want to log it. An alternative that you can do here is to use something like Loguru and save it into a file in a structured way, where you actually take this, turn this into a JSON, and you make maybe a nice delimiter, and then you log it with the delimiter and then the JSON, and then you can look afterwards in the text file, just find those things. You can make your own special it's a bit out of on the scope of this one, but you can make, instead of you have info and debug, you can make another kind of level of, let's say, monitoring, and then you filter by monitoring, and you take every row and you just split it and get immediately your data in a structured way. So it's really nice. And it would work with most platforms because they all have logs. And this is the serve. Again, it just runs Unicorn. Something I got used to do way more often than I had to when I was working in ZApp. They are extremely talented developers, and you see them do magic stuff all the time, and you start using Bash more often than you would imagine. here is a little special case of ZTab. ZTab has a feature called mount, and that kind of, it's a lazy evaluation. So when I use this thing, let's say I want to check any model I want, if I use mount, then even if I can have in my data set a lot of data and tens model and a lot of other elements and tests that I don't use, it's not going to bring them on. It's just going to bring the data that, just the model file that I need, just the code file that I need. It's only going to have the relevant stuff. So it's just very efficient, all the benefits of lazy evaluation. And that's kind of how we do the serve. Now, let's try it and see. Now, the daemon is the daemon of demos, and he's going to be here. So we're going to have, I'm going to run the train. And again, at this point, we can have a look what we have, and I can add a description and a tag. And the tag we're going to talk about in a second, but I can run it. And this is me just testing everything. This is not going to go to production. This is not ready to be anything yet. It's just me see that everything working. And this is a small feature I made where, because I know at training, I save for the model which was what was the commit in the latest split. I go to the remote split and check what was the changes there. So I can tell, and in this case, there was a change. So we download the new data and it crashes because that's how it works with demos. And then it runs the test. That's another important thing to do. People think that in data science, we don't do tests, but we're going to show them. So if I do tests, I check all, this is for the data elements. And for my trainer, I check that it goes. I check the artifacts are created. I check that predictions are nice. Well, I didn't check that the predictions are nice, but I checked that I got an evaluation and then I got a predictor. It's a good start, because my server actually is going to check that I can predict it, that all the things I care about exist, and I can check the server as a server to simulate it and run it locally with the input, which I already have the example because I've implemented it as the server. So I can check it out and see that it works. So very nice. And this element is going to go into monitoring. We're going to discuss it in a second. Is it going to be thingy? Okay. Git commit and merge. Training. So this is another shortcut by Omizesh if you want to check it out later. But I just do a lot of the other elements. And wait, we can actually look into just like our dev model. This is, for the sake of it, could have just called it dev. But this is where I always merge the latest version of my models. And again, we just added rows, so I get them. And I probably should do that when you pull the data in, the strategy of the merge should be theirs. So it always get the latest. So this is another hack which I should implement it probably. So now this model is more sophisticated, because if we're going back into what we discussed earlier, we now just looked into the dev baseline, but I simulated this entire thing yesterday. So I implemented all the different ones. So you go here and then you implement the dev linear regression, and then you implement this one. And I think this one should be an XGBoost model. So yeah. So this one is the latest version from the XGBoost version with the PCA and all the fun things around it. So before we look into it and what it means to be training, let's look to where the tag are and where the prod kind of branches are sitting up. Actually, I knew I would never have enough time. It's just not who I am. But as I said, I think in the introduction, it's going to be way overly comprehensive. So when you follow this, we just talked about it, you can save the elements and we can check it out in a second. And then when we're done and we are happy with it, we merge the code, the model, everything we need, we merge it kind of from dev to prod. And this is where you can only pull data, run the training, the test, and commit everything and tag it. So you don't write code here, but you still create a new file for the model. And if you have more file that you just uploaded in the cloud, then when you pull it, you can retrain here again and again and again. So the cycling of retraining with new data is automatically kind of set up for you. You don't really need to be worried about it. You just make sure that the implementation works. And then every time that there is a new data is coming in and the split has new data, then the prod will have it with it. And this can create more and more prod models. So the way it would look if I'll run it in a second is that when you do -- tag, it will check if you need to bring data. And then if there is no, it will check what is the latest tag that exists in remote. If it's prod 2, it knows that prod 3 is next in line. And because of it, we're going to use it and we save it as a parameter during our training. And at the end, we're going to tag it because I want to collect everything, commit it, and then tag that commit. So anytime I want to get to this model and check where it is, I have the right tag for it. Now, MLflow by itself automatically creates for each experiment, it creates a folder, and for each experiment, it has a bunch of runs, and for each runs, it saves a lot of different files. And I'm going to move here a bit more steps so we can see how it looks like in one go with the monitoring. But this is the trick I showed you before. I can check what was the latest version of the data in the split branch. Because if the split didn't change, there is no reason to pull the data. There is no reason to do any copies. Now, file deduplication will save me from doing it, but it will take the time to evaluate it, and it's a shame. Again, depends. Some tooling will just know not to do anything, but it's just a nice hack to have. And it's very important. The same PyTests I run for testing, I run them as I'm running the training. I will not upload something that doesn't pass my training. I will not share it. I will fix the problems. And then I don't, if I have this, why if I have a prod 3 file and it doesn't work, it doesn't work, I will never see logs with that tag upstairs. I will never see logs of the locally as well. Well, locally I will see it, but I could easily find out because it's failed and I could see where it failed. So I don't upload if it fails. And using your PyTest as part of your training is just good best practice. I didn't hear a lot of people say it, but from the moment I started doing it, I never stopped. Yeah, it deserves another meme. So I'm going to continue here straight to monitoring and going to go into the demo in one go. I can see we have about 20 minutes. I will try to do it in 15 and then leave 5 minutes for questions. I hope you don't do questioning on me. So look, monitoring is one thing that most people don't get to, and when they get to, it's only in a corporation, and it's something that's pretty late, so it's not as commonly talked about besides people who build product for those. But the idea behind it is that every time I get a prediction, I save the prediction, what the data it had, which prediction it had, and what I like to do because of this framework is to save which tags it also held, and which data it was holding and which run it can have. And that means that I can use it later and we can quickly go and have a look at how it looks like, but I can look and build data drift kind of alerts and evaluations. I can find if a model is doing something weird in production, I can go and see all the parameters that he was built on. If it's an XGBoost, what type of parameters it ran, all of these different elements, I can find them from the monitoring. So everything leads to everything. What we talked about, the complexity of the other questions we have. If a model does something in production, I can always check out that tag and see everything, which data it was used for training, which parameter it uses, what kind of evaluation it did, which everything is there, all the constant, the code, the bugs, everything is in one place, and I can always get from it from anywhere to anywhere. Now, MLflow, the way it runs and create those folders, it has a nice kind of UI you can run. And here I implemented, you can run MLflow UI and you just get the UI, or demo MLflow, which will run it with a mount from the remote. So every time after I did a training, I upload it into the remote. So again, it's in the cloud, it's safe. I don't need to pay for any other kind of weight and biases or any other platform. It's just on my Git, I have the data and I can just directly mount it and run those visualization. And because I saved the commit, I can go like, oh, this commit did this good, this commit did this good, and so on. So it saves me a lot of trouble. And the only thing that the reason that this is, and this is the most tricky, but I think insightful part of this entire idea, because I figure out which tag it's going to be before it's training, and I upload it afterwards, in production, that thing is going to be prod 3, because this is embedded into the model during training. So in theory, you don't commit and now you know that port 3 is going to point to something. You first figure out which one is the tag you will have later on, and then you train it, you add it as a parameters, like it's like any parameter of machine learning. You add also the data commit and other things, so you can tell later on if a model is doing better because it has more data, or it has a different data commit, or it, which also apply for feature engineer and so on. So this will become more information you can use to analyze the models you have. And then after you decided of it and you saved it during training as part of what you save into the model, you can push the branch and get it. So, that solves a lot of problems, and it's really nice. Now, I gave a few examples of what you can do in the monitoring branch, like data distribution outliers. You can save there the models for outlier detection. You can save there the code for your alerts. And here's a few tools we're going to look at evidently, again, if we have time. And I'll just go through it because this is our last branch, and the analysis branch, which is, again, it's a place that normally people just do it on a different project and they just do everything in a different place. And you shouldn't have to. It's where you're going to run like a forward test where you have two models in production. We're going to show how you can deploy different ones by just changing the tag. So you can serve a specific tag. It will just get that one and only serve that one. So you can put some of your input, some of your users are going to, or your infrastructure is going to ask the old model, 1% is for the new model. You see, you get the reaction you want, and then you know you should update your model and change it. And then it's not very common, but you should definitely do it, is a back test that after you're done, you actually switch it around. You move 99% of the queries you send to the new model, but you still send 1% back, and you want to see the same effect in reverse. If you don't, it's a flag, and you should go back and kind of figure out what's going on and why do you see the change, or what's going on. So it's a good kind of a rule of thumb to kind of follow. And also you want to know which model did worse or better. It's really easy, nice to be able to have a place where you can just download all the models and compare them and so on whatever specific data sets. Because maybe one data was training one and one with the other, and you want to compare them on the new data that you got, not on the old one, because one of them might have already looked into it. So and this is again where you can find. I think that is actually not the right code, but the QR is the right one. So we also have the link in the presentation earlier. So don't look at this one. This is an old version. Look at the new one with the PyData 23. Now I'm going to go back into the code and we're going to look at all of those elements, and then we're going to summarize. So okay, we are looking at the code. Yes. So now. So we are now in the dev model, and if I do git not git demo. First of all, I can do like show me all the tags that we are now holding. And we're holding nothing, I think. This is a PCX boost, and this is still the dev model. So this is this green one that with the latest version of it. So this I can still run here tests, but there is no version, no current model here. And what we're going to do, we're going to train it, and we're also going to tell it to tag the model at the end. Now, if you look at the data currently, because we just brought it from scratch, it has this version. But as I said, I'm going to persist on the first training. I'm going to persist it with the PCA. So I'm going to also, and now this is where normally things should fly in because it's a demo. This should crash, but let's see. Dum dum dum. So in the meantime, I can have a look here on the changes that I had to my code. So I added an autolog, which I just forgot to do earlier. I keep all kind of other parameters that I care about as part of the data. Yeah, it had an issue. Perfect, but still made it. Still passed the test, so I know it would work. And now I added the persist So whenever I get a model, and this is a bit of a trickery, you don't have to do it, but I kind of, when I do an experiment, I send the columns and I check if the columns exist. Because if they exist, I don't need to retrain the PCA. I can just do prediction on it, and I know my model already has it. So I recommend for you to go and kind of check it out and kind of see the trickery that is going on in this case. But again, I check if the number of PCA columns make sense, and then I don't retrain. Let's go into the actual place. So here is the XGBoost, and I check unless you force me to train, because again, at the end, I would like to train on the entire data set. But when it's done, I check if the new columns exist, and also they should be the right amount of columns that I would like. And if not, I do it from scratch. I do a standard and PCA, then XGBoost, and I train it on the original features. And when you go back into the training, then after I did the training, and I keep the model that I want. So if you ask me to persist, I can go take only the persist part. I remove the XGBoost element, and I just saves the new. I just save the new files locally, and I keep the original features. I add the target, and I add the new PCA features. And now, if I look at the head, you can see that it didn't work. Did I tell it to persist? Oh, that's the real that's what you would expect. This is up to date. Interesting. We did tell it to persist, right? We did. Interesting. Let's have a look at a different element of it. I hope we're going to do it next time. But you see that I figured out already what should be kind of the model, and then at the end I tag it at dev model 7. And if you would look now, git tags poi is like the one of the commit I'm looking now. So this is the commit that we have now, and I can do something like I can serve it. So this will serve this one. I can also use tag to serve any model I want. So let's just run it locally. So this will run the server, and I'm too lazy, but you can go here and there is a documentation on /docs, but I will just go here and I will run like query it 50 times, and it just query it and does the predictions. And the server, again, you can see behind the scene, every, I think, 30 seconds or so, it will take the most recent kind of tracking information for monitoring. And this file, and this is another hack, use different files to make sure when you upload to the cloud, so you don't run over one or the other. It's just a way to work with kind of streaming data in a more safe way. So every time I run it, I get a new file. So I don't make a mess over those things. And yeah, done uploading. And I can also do and look at the predictions when I was talking about the monitoring. And you can see the latest one that we had, this was the commit. This was the branch it was trained on. This is the parameters. I actually have all of them, but I don't print them to screen. The tags, the data commit it was trained, all the information that is relevant for me to kind of figure out where I stand and go from one place to another is here. And this is the same data that is now running on the monitoring branch. And let's go for prod. So prod is the latest version of this model. Do we have? Yeah, this is on prod 7. This was the latest training, but I'm not afraid to try again. Try tag persist, and this in theory should just work. And if there is any problem here, I go back to dev model, I fix it, and I merge it back. There might be changes in this specific project because there are changes in the README, which I made. So you might want to consider, but if you just starting, you can just go and try to go into the data add and data split and go into those kind of play with them and see that you can always retrain and tag and persist. There is a bug here because the file, I'm not sure where this file is. But I think I said too many good words on MLflow, so they came after me, which is not surprising if you know the guys. Okay, I will use the next 3 minutes to just show the other relevant branches, and it's pushing the branch. All this main thing, all the code of the logs of the logging is just like sitting here. So this is what it prints at the beginning. And I made this so it will be easier to look, and all the documentation or kind of the help you have is written in here. So all the logic and the stuff are here, and you can go, for example, let's go into the train one that we saw. It's kind of what you expect. I'm trying to pull the data. This will not pull if it shouldn't, because it checks the model I have locally. If the commit that it had in the remote at the time of training is the same one, and then I just run a fit. I run the same parameters we had before. I'm a big fan. I don't know if I said it already, but having all the configuration in a single place. So even things that I need a bit of logic or other way to get, like I just put all of them kind of special constants sitting like this, and I just have all the constants of all the apps sitting in one place. And it's very easy to kind of be on top of what's going on and to know where to look when you have different changes. So I'm a big fan of it. So we do the training, then I run the same PyTests that we ran before. We see that it passes or we stop if everything is okay. And also it's another validation, the predictor is okay. We upload the tracking information so we can find it later. And then I commit everything and I just run git tag. So at the end, I just like, I run those things, and where's the git tag? And this file is doing the git tag trainer. It's just implemented here. You're welcome to look at how I implemented this whole tag thing. It's not very complicated. You just a lot of git commands, and then you take the number at the end and you figure out. So yeah. So let's check out the monitoring branch. No? Yeah, yeah. So the only element here is that I hope it's going to work. I don't want to run it. I hope it's just going to look good. And if not, you're welcome to run it later, because I don't think the visualization that I set up here would work also with the... no, you don't want to open it? I know why not. Here's a great example. It looks at this file. It's a heavy file because of the images. Then it's not materialized. It's only a pointer of a place. So I'm going to go here and I do git z materialize to that folder, and bam. Well, I hope now you can at least be nice and show and kind of... Yeah, yeah, it's okay. So this is an evently report. I don't know why it doesn't figure it out, but in this place now, this is the same report we talked about, the monitoring. I don't have the data here. I only have the monitoring of all what we saw earlier, the running. When I did demo latest, you saw all the predictions. I just have those, and the ML runs, which I got from all different experiments that are sitting here. Maybe it's a good example of how it looks like. You have some data sets, but let's look. This is in run, and you have a parameters, and like every other element is relevant is here. And for some reason, each one of them is kind of a value as a file. But I bet it works very well for distributed stuff. But again, it made the bug for my system, so that's not really nice. And again, when I log the model, it also is the model here, not in this case, but I hope in some other places, the data set was using and so on. So it's a bit of an overhead, but it works. So how would the monitoring look like? Just a cool example of using it evidently. Oh, no, or you can't handle it anymore? Okay. It's class too heavy. Okay. So in this case, we can see, well, I added some noise to get something cool because I didn't want to simulate it during the demo. I see they have 3 minutes left. So here is an example. This is how I can keep up on like which distribution. I can see the prediction is drifted a bit from what it should be. So I can make an alert. I can just get this JSON and implement it, go to the Lambda and send this Slack message or whatever and figure it out. So you could just implement it with a few lines. But the important part is you have all the information next to you. You don't need to get to it. It's just here because wherever that branch is running, you can git pull, and you're going to get the latest version of that models. And the same thing is also going to be relevant for the analysis branch. Is there any changes? No. Yeah. No, did I save it on a different place? Yeah, it's on analysis. And here, the same kind of concept. I can have the data that I was using for the training, I have it available for me here because I can. And this is kind of a nice sharp evaluation of the model. And I can take any model straight from the branch it was sitting on, read it here, kind of compare it, build it, see how it does, get the result and go, oh, this model thinks that sex is really, it's really helping you for your result. And what is here? The BMI is really bad for you and so on. So I can do the analysis and all the information in one place to manage the entire project. So I use all the time. At the beginning, I thought maybe an hour and a half is not enough, but I feel like we kind of we managed. So um, can you? Yeah. So this is a summary of everything we went through. So we went through all of these different elements. I know it was very technical. I know it was very complicated, and this is kind of like a Nolan movie. I hope in a way that you rewatch and find new things you that are useful for you later. I don't expect everyone to get everything in one go. But everything within its own context is actually not that complicated. There is no very difficult aspect of it, but there's just a lot of things to do in our field. So again, you always upload to raw. You can do the splits early on. You can, from here, move corrupted and bad files to a different place so no one will have to deal with them besides the people who deal with the automation. And then you develop on kind of feature branches like the dev baseline, the dev linear regression. You can keep data within intermediary results and other kind of pre-processing elements. You keep them all, you put them back into your dev model or just dev. It depends how many different solutions you have that you want to solve in the same project. And then at every training, I always like to tag it when I'm happy with it. So I also tag so I can always go back and see what's going on. I move it to prod, and when I'm prod, I'm tagging it. And that is the one that I can deploy later. Now the results of that of the monitoring data is going to the monitoring branch. When I was training it, I uploaded the model tracking. You don't have to um, you don't have to use a single one. You might want to have a different one for tracking for monitoring, but for this one, I did it the same one. And again, I develop on the dev monitoring and merge it into monitoring. And the analysis, I actually feel a bit comfortable just writing code because it's just notebooks and stuff like that at this case. Now, I left you no time for questions, but I do have a slide for questions. So if there are any, and if you give me the time, then we can do it. Otherwise, the mic goes back to you. Thank you, Claude.
Wonderful. It was really, really amazing workshop, and I'm very happy that that we'll have a recording of that, and you will be able to get back and just dig deeper. Yeah. So actually, we have some time for questions. If there is any question, we still can use like a couple more minutes to to discuss.
Sure, that's what I'm here for.
Also, if you will have some questions afterwards, please remember about Slack. So you can definitely ask some questions on this event Slack. This one for all. And yeah, I saw that Yonatan, your mentoring sessions are already booked. You have booked all the mentoring sessions. So I hope that you will have a great time there, and I know that you will be very, very helpful for the mentees. So that's awesome. So for the questions, going once, going twice.
Yeah, I don't think many people can survive an hour and a half of this kind of intensity in material. And also, it's very hard next to all of these AI generated typos to kind of concentrate. But I don't use AI without typos. It's not my style.
And MEMS helps a lot. to concentrate. So yeah, thank you for doing that. The recording will be available perhaps on YouTube. You definitely will get an email on that, and yeah, please use Slack for questions. And thank you so much, and see you on the next session.
Thank you. Cheers. Bye bye.
Cheers. Bye bye.